guys, in this new video we will talk about TLC troubleshooting. So the most common problems you can encounter when you are doing TLC. What are these problems and how to solve them? Let's start. Here is a scenario where a student approaches the teacher and says, I have got a huge spot on my TLC. What should I do? Why is this happening? One of the first mistakes is huge spot on the TLC plate. It's an abnormal situation. Obviously, large spots are a problem because it may be impossible to tell if there is only one sample in that large spot or if there are multiple samples in there. Therefore, large spots make it impossible to identify the number of bands and to calculate the RF. A possible reason for this large spot is that your sample is too concentrated. So you simply need to dilute it with more solvent and repeat the TLC with your diluted sample. When spotting, always try to keep your spot as much smaller as possible with a diameter no larger than 1 to 2 millimeter, so that you won't end up with these huge spots. Huge spots that can be also a result of inexperience when you spot your compounds onto the TLC plate. Another typical mistake is the solvent eluting unevenly, where you see it rises higher on one side of the TLC while staying lower on the other side. What causes this? This issue is likely due to a damaged TLC plate, where parts of the silica have chipped off in some spots on the base of the TLC plate. So how can you solve this problem? You need to be smart. As soon as you notice a damaged TLC plate, cut away that area. The most common issues is damage to the corner of the TLC plate. So in this case, you can make a 45-degree cut at the corner of the TLC plate. In this way, you get rid of the chipped silica gel that causes the solvent to elute unevenly. So definitely eliminate the part of the silica which are damaged to solve this problem with the solvent. Third problem, and how typical it is, the student in tears in front of a TLC with a long streak. This is indeed very common. So what to do when you get this ugly TLC with these huge streaks on it? Once again, this is a problem because it's impossible to see how many bands are there when one band begins and the other ends, and also it's impossible to calculate the RF. What causes this problem? It's very likely that your compound is acidic or basic, and this causes problem during elution. Now, how to solve this problem? If your compound is acidic, it's advisable to add some acid in your eluent mixture. You can add a 1% or 0.5% of an organic acid. The most used one is, of course, the acetic acid. So you can add 1% of acetic acid in your eluent mixture and see if this can solve the streak. Conversely, if the compound is basic, use a base. You should always use an organic base. So you can use, for example, triethylamine. You can add 0.1%, 0.5%. You have to try the percentage that works. And so you add this small amount of triethylamine into your eluent mixture and see if the situation improves. Fourth problem, dealing with sample that get damaged on the silica gel. So compounds that are destroyed during the elution because they interact with the silica and they decompose. For example, this is typical for acidic sensitive compounds because the silica is slightly acidic. So if you have compounds that are highly sensitive to acidic condition, they will be destroyed on the silica during the elution. So how to prevent this decomposition? In this case, you can try to add a base in the eluent mixture. So you add a base in your eluent mixture in order to neutralize the acidic sides of the silica. You can add between 0.1 and 0.5% of base. Again, you can use triethylamine and see if this works. If this doesn't work, you can switch to stationary phase. Change stationary phase. Use, for instance, alumina, because alumina offer you the possibility to choose even for neutral alumina, basic or acidic alumina. So to recap, when you're dealing with acidic sensitive compounds, you have two possible solutions. add a bit of base in the element mixture, or change the stationary phase, for example by using alumina. This is how you can handle acidic sensitive compound that degrades on silica. Now, the last problem. The last problem is similar to the previous one, because it's anyway dealing with compounds that are decomposing on the stationary phase of the TLC. But the question is, how do we can understand that our compounds are really decomposing on our stationary phase? So when compound degrades on silica or on your generic stationary phase, you will see multiple spots. But how to actually verifying is these spots are from decomposition? You can do what is called a 2D TLC. A 2D TLC is specifically designed for sample that degrades on silica. Once you have established that the sample degrades, you can identify the most suitable solution, as we have seen previously. Now, if you want to know how to perform a 2D TLC in the lab and what a 2D TLC is, you can go on my organic chemistry laboratory course, which is on my website, opperchem.com. That's all for this video. Please share and subscribe, and see you to the next video.